Seventh graders, let's prepare for this chapter 6 test. This is the study guide, and I'm hoping it helps prepare everybody and gets them an A. It says the probability of an event is 15%. Describe the likelihood of the event. Well, if there's 15% out of 100, that's 15 out of 100. Let's just pretend that we had a scale here, and this was 100. And if we're, the middle of it would be 50, right? And, well, the middle of that would be 25. And so 15 is going to be somewhere about right here. So it says the probability of an event is 15%. 15% says describe the likelihood. If you only have this much chance out of 100%, it is very unlikely the event's going to occur. So this would have to be unlikely. All right, let's go to number 2. You randomly draw a marble from the bag, record its color, and then place it and replace it, okay? So you're going to stick it back in the bag after you take the marble from the bag. You draw a blue marble 3 out of 50 times. What is the experimental probability that the marble will be blue? Remember, theoretical probability is what should happen, but experimental probability is what did happen. And it says you randomly drew this marble from the bag, right? So you draw a blue marble 3 times out of 50, and you replaced it. So each time there was the same number of blue marbles, right? So we're saying that's 3 out of 50. Now, what is 3 out of 50? Well, that is a fraction, and every fraction is really a division problem. So I'm going to take my calculator, and I'm going to take 3 and divide it by 50. That's 0.06. So I'm going to go ahead and put 0.06 here. Now remember, we're trying to find the percent. So we have to move this decimal 2 places. And that means this is going to be 6%. So the experimental probability is 3 out of 50 or 6%. All right, let's go to number 3. There are 6 red marbles and 11 orange marbles in a bag. You randomly choose one of the marbles. What is the probability of choosing a red marble? Remember, there's 6 red marbles and there's 11 orange marbles. Now you might be tempted to put 11 under here, but remember, it's the probability of choosing a red marble out of the bag that has both of these. So I have to take 6 plus 11 to know how many marbles are in the bag, and that's 17. So this would be 6 over 17, okay? So what's the probability of choosing a red marble? Well, let's see, 6 out of 17 would be 6 divided by 17. That equals 0.35. You notice the 2 here is less than 5, so when I round up, it's going to be about 35%. So what is the probability of choosing a red marble? 35% or 6 out of 17. Next we have number 4, okay? Number 4 says, use the table to predict the number of times you will spin 4 when you spin the number 100 times. All right, so remember, first we have to count up the number of times that we show on the table that it did get spun. Let's see, we got 11 plus 8, and that's 18. And 18 plus 10, that's 28. So all this is 28. All right. Actually, it's 29. I'm sorry. 11 plus 8 would be 19, plus 10 would be 29. So I'm going to make that correction. So from there to there is 29. And now over here we have 1, 2, 3 sevens. 3 times 7 is 21. So I can add 29 and 21 together. That's going to give me 50. So I know there were 50 spins. And it says, take the table to print the number of times you spin a 4. Now, we spun a 4 7 times, okay? So don't look at the number 4 because in actuality, we're looking at the number of times 4 was spun, right? You spun 4, so that's 7 times. So that means 7 out of 50 times, it came up to the number 4. But it didn't ask us that. It asked us about, can we predict the number of times you would spin 4 when the spinner is spun 100 times? So we have to put this equal to 100 spins. Remember, the bottom of this fraction represented the number of spins. That's why we went ahead and added all these together, right? So we're indicating 100 spins this time. We're going to have to put X here, and now we cross multiply. We're going to take 7 times 100, and we're going to take 50 times X and put them equal to each other. Well, 7 times 100 equals 50X. That's 7 times 100 is 700. And 50 times X is 50X. Let's remember, we need to get X by itself, so we're going to have to divide 50 away. We're doing this because if 50 is being multiplied to X, the only way to get rid of it is to do the opposite, divide it away. And whatever I divide from one side of this equal sign, I have to divide from the other. Now I have 700 divided by 50. So let's put that in our calculator. 700 divided by 50 is going to give us 14. So X is equal to 14. Which means we can expect the number 4 to be spun 14 times out of 100 according to our experimental probabilities. All right, let's go ahead and go to number 5. You roll a 6-sided number cube. Well, that's a dice, right? 6 sides of a number cube is just going to give us a dice. Now this says, what is the theoretical probability of rolling a number greater than 5? Well, we know the sample space of a cube is 1, 2, 3, 4, and 5, and 6. And now we're saying the probability of rolling a number greater than 5, well, there's only one number that's greater than 5, and that's the number 6. So in essence, there's a 1 out of 6 chance, 1 of 6. If we were to put this as a percent, we would say 1 divided by 6. That would equal 0.16 repeating. So this would be 0.16 repeating. And then we move that decimal over twice. That's going to give us 16.6 repeating percent. And I'm going to go on a limb here with this one that we did over here. I want to make sure it doesn't say the nearest 100. I probably would accept this 35%, but if we were going to go ahead and put a decimal underneath there, I was going to redo this one, 6 divided by 17. That was a 2 and then a 9, so we'd round that up to 3. So if we're going to do it to the nearest 100th, it would be 35.3%. Okay? Let's go back down now. We were at number 5, and now we're at number 6. Which data display is misleading? Okay, when I'm looking at these two, I see that one goes to 0, 20, 40, 55, 65, and then 70. Okay. I got to tell you, because this goes up 20 and then 40 and then 55, this is like a difference of 20, right? This is a difference of 20, right? Because 40 minus 20 is 20. But 55 minus 40 is 15. So that's only a difference of 15 in this area. And then 65 minus 55 is 10. So that's only a difference of 10 in this area. So this is 15. This is 10. This area was 20. This area was 20. Now this bottom one is 70 minus 65. Heck, that's only a difference of 5. Can everybody see that? So let's look at this one. This one goes up 15, 30, 45, 65, 75, which means 15 minus 0 is 15. Then 30 minus 15 is also 15. 45 minus 30 is 15. 60 minus 45 is 15. And 75 minus 60 is 15. So these are all in proportional increments. So the misleading one has to be this one here. Okay? It's misleading because the y-axis is not proportional. Okay? We got 20, 20. Heck, down here is 40, and over here, this total combined area up here is, let's see, 25 plus 5, that's 30. So this little area actually represents more data than all of this big area combined. So, well, that was the last one. Looks like we're all ready for the test. Hope that wasn't too complicated. I'm really feeling like you're all going to do great on this test tomorrow. So I'll see you in class, and good luck.